our things. So we're gonna take a look at a bullet and block problem here, and hopefully that helps you a little bit. So we've got a 14-gram bullet that is fired into a 121-gram block of wood. The block of wood is stationary. It's on a horizontal surface, so the bullet sticks into the block, they slide to a stop. We're given the coefficient of friction, and we are going to assume we're on Earth where gravity is 9.8. So we got some questions to answer here. How much work is done by friction in order to bring that block to a stop? How much kinetic energy is lost as that bullet and block slide to a stop? What's the velocity of the block and the bullet just after the collision? And then we're going to figure out the momentum of the bullet and block after the collision, which is the same as the momentum of the bullet beforehand, because momentum is a conserved quantity. And then finally we can get to the thing we're actually trying to figure out, is how fast is that bullet going before it hits the block. So if we look at our 4 types of problems, that list we've seen a couple of times, which one would this be? Would it be an object sticking into a stationary object and sliding without friction? Would it be a moving object colliding with an object sticking into it and sliding across a surface with friction? Is it a pendulum? Please say no. 2 objects colliding head-on? I don't think so. Yeah, it's the second one on the list where we have an object run into a stationary object and they slide with friction. All right, there are the answers to each of these steps. Let's work through them. So, how much work is done by friction? Well, work is the force of friction multiplied by how far it slides. Force of friction is mu times the normal force, and then how far it slides. So we got mu, and the normal force is going to be mg cosine of the angle. Well, that's just 0 degrees. And how far it slides. So this is just going to go away. And if we work through this, we have this mu of 0.7. The mass of the block is 121 grams. That's 0.121 kilograms. And the mass of the bullet is 14 grams. That's 0.014 kilograms. So our mass is 0.121 kilograms plus 0.014 kilograms for a total of 135 kilograms. So we take our mu, 0.7, our mass, 0.135 kilograms. Gravity, 9.8. And we have this distance it slides, 8.3 meters. So that's the work. I'm going to round this a little bit. that's the work that friction did. Second question is how much kinetic energy is lost? Well, it slid to a stop, so it lost all of the kinetic energy. So the only way that friction could do this much work is if that's how much kinetic energy we started off with. So, same answer for both of these. So we'll just list that over here. So, kinetic energy of the bullet and the block just after the collision is this 7.687. So now we're looking at the velocity of the block just after the bullet hits it. Well, we have a kinetic energy. That's at 7.687 joules. And kinetic energy is the mass, but it's the total mass. So it's the bullet and the block. And this is the velocity after the collision. But we're trying to get that all by itself, so we multiply both sides by 2. Divide both sides by the total mass, bullet and the block. Take the square root. So we got 10.67 meters per second. The next question is how much momentum does everything have after the impact? Momentum after is going to be the total mass, because after the collision the bullet and the block are moving, multiplied by how fast they're going, 10.67 meters per second. One 0.44 kilogram meters per second. So we'll just put that up here. Momentum after is 1.44. Kilogram meters per second. All right, we're almost done. So now it asks, what's the momentum of the bullet prior to the impact? What's the momentum of the bullet before? It's going to be the same as the momentum of the bullet in the block after, because momentum is conserved. So momentum of the bullet before is what we solve for after here, out here. And then finally it's the velocity of the bullet before the collision, momentum of that bullet before. It's going to be the mass of the bullet, and only the bullet, because beforehand, only the bullet is moving, and the velocity before the collision. So we're going to take this and divide by the mass of the bullet, but it's got to be in kilograms. So 14 grams is 0.014 kilograms. Kilograms cancels out. That's going to be the velocity of the bullet beforehand. And we get 102.9 with a little bit of rounding meters per second. Okay, hopefully that helps.